Okay, so let's learn how to find the derivative of a function by the first principle method without using the formula. Now, I already have the formula displayed over here and it is very useful to know, but sometimes you might be asked to solve without the formula, or maybe you might just forget it. Hopefully not, but if you do, then you should know how to proceed with that. So let's learn by a few examples. Our first example is the following function y is equals to x square. We'll mark it as our equation number 1 and we will state the following line. That is, for a very small change in x represented as delta x, let the corresponding change in y be delta y. Now since it is calculus, we will be dealing with very small changes. That's why we're using delta x and delta y. Now we can rewrite our equation number 1 as y plus delta y is equals to x plus delta x whole square. Now make sure that you're adding delta x to the value of x itself, not to x square, because that would have a totally different meaning. Now we'll subtract equation number 1 from equation number 2 and we will simplify it. So you'll get delta y is equals to x plus delta x whole square minus x square. Now we will divide both sides by delta x and we'll put limits on both sides. Why are we dividing? Because we are trying to find out the rate of change. That's why we need to divide by delta x, and since delta x is a very small value, that's why we are stating that limit delta x tends to 0, because it's very small. So we'll write it. Limit delta x tends to 0, delta y by delta x is equal to limit del x tends to 0, x plus delta x whole square minus x square divided by delta x. Unfortunately, we need to write the same thing again and again. Now the right hand side can be simply written as dy by dx, which you know is the expression for a derivative. So we'll write it again, the same thing. It's okay. Now after reaching this step, we usually have to use certain identities to simplify our equation further. So if you look at the numerator, you'll notice it is in the form of a square minus b square. So we'll apply the following identity and we'll try to simplify it. Try to solve it with me, it will be easier to understand it that way. So once we have simplified it, you will notice that the delta x is present in both the numerator and denominator, and we can just cancel it off, and we have just gotten rid of the reason for the indeterminate form, that is the 0 by 0 format that it was getting in. So we'll just substitute the value of delta x as 0 and we'll get our answer as 2x. Now we'll take a second example. This time it is a trigonometric function, that is y is equals to sine x. This one's quite easy to find too. We'll mark it as equation 1, and I'm not stating the statement again, but you absolutely have to. So we'll mark it as equation number 2 and we'll do the same process again. We'll subtract 1 from 2 and we'll simplify it. And we'll add the limits on both sides and we'll... Okay, sorry, I need to explain this. So do not add delta x to the function, do not add it to the sine function. We are adding delta x to the angle. If you add it to the sine function, that would mean that would again have a totally different meaning, and I don't know why I always mess up this sentence. So we will divide by delta x on both sides and we'll put limits on both sides and we'll get the following equation. We'll try to simplify it, and once we have reached up till here, you'll notice that this is in the form of the formula I displayed in the starting. The only difference is I'm taking h as delta x, otherwise it's the same thing. We are just using a few additional steps to reach up till that formula. Now after reaching this step, we have to use certain identities to simplify it. Since this is a trigonometric function, obviously we'll use a trigonometric identity. This is in the form of sine c minus sine d, so we'll apply that identity and we'll try to solve it and get an answer. I hope I'm able to explain the things because I'm speaking at 2x, so that when you put it on 2x, you can, I don't know, understand it in 4x. I forgot to add delta x over there, do not forget it. So after reaching this step, you'll have to use the concept of standard limits. So if you recall, when limit x tends to 0, sine x by x equals to 1. However, the problem is the denominator is not the same as the angle, so we'll have to make it equal. So we'll divide it by 2 and we'll multiply it by 2 so that we do not introduce any change in it. Then we'll simplify it and we will cancel off the like terms and simplify it. We just need to simplify it. Yes. So once you've done that, you'll now, we have gotten rid of that delta x in the denominator. Congratulations, you can substitute delta x in the numerator as 0 and you will get your derivative as cos x. And that's how we find the derivative by the first principle method. Follow to see more examples. Thank you.